So let's see how we can find the equation of trigonometric function being given certain clues. So we're told that we're dealing with a cosine. It has a maximum at minus pi over 2 comma 2. So let's sketch that point at minus pi over 2 comma 2. It's over here. I'm going to write down the coordinate as minus pi over 2 comma 2. That is a maximum. And we have a minimum at pi over 6. So here we have pi over 6 comma minus 1 over here. So I'm going to write down the coordinate pi over 6 comma minus 1. And that's a minimum. If we're dealing with a cosine, just keep in mind that a cosine has a particular period. And that period you can use 4 distinguishing pieces. So the cosine wave starts at its maxima, ends at its maxima, and in between it has its minima, and in between maxima and minima we have the x-intercepts, or the midline, the crossing of the midline if we have some vertical shifting. So this is going to be a maxima, then we're going to have another maxima, minima, and the midline. The midline is going to be half of the graph vertically. So it exactly cuts the graph in half vertically, and we go from the midline up, we have the amplitude, and from the midline down, we also have the amplitude. So if you notice right here, we're starting at the maxima, and right now our clues are going to end up at here, at the minimum. So we are given this and this. So we have half of the period. So if that is 1, 2, 3, and 4 squares, we need an additional 1, 2, 3, and 4 squares to complete the other half of the graph. So we can end at the other maxima. So we're going to close this to have the same sketch as we had on the cosine wave. Then we're going to subdivide this in half once again, and this in half again. So we're going to end up with 4 pieces, just like the original sketch. And then the midline, we have 1, 2, 3, 4, 5, and 6. So that means that the midline is going to be 3 and 3. So the midline is right here. So once we have the midline, we can complete the sketch. We end at another, let me use a different color. We have another maxima here, and that's going to be at 5 pi over 6 comma 2. We're going to have the x, well, in this case, they're not going to be the x-intercepts. They're going to be the points that are exactly over the midline, and the graph is going to be roughly this. So now that you have completed a period, you can actually write down the equation. And we know that's going to be y equals, we know that there's going to be a cosine, that we're going to have a k. That's not a good looking k. So we're going to have a k over here, then x minus b, and then plus c. And here we're going to have the a, b, based on our amplitude. So let's figure out the amplitude. So the amplitude is from here, from the midline, either up or down. So each square is 1/2. So if we have, this is 1/2, this is also 1/2, and this is also 1/2, because from 1/2 to 1, there's 1/2. From 1 to 3/2, and from 3/2 to 2, the distance is 1/2. So the amplitude is 3/2. And because it starts at the maxima, it's going to be a positive cosine. So here we're going to have a positive 3/2. Now, we can go for the shifting, and for the midline, the one that should be a bit more challenging is the k, because we need the period, and then we proceed to get the k. So in this case, the midline is exactly at 1/2. So midline, the midline is at y equals 1/2. So the midline will always tell you where the c value will be. So here you're going to do plus 1/2. Now, because the graph is supposed to start exactly over the y-axis, so that should be the y-axis, that means that is no longer starting at the y-axis, but now is starting at minus pi halves. So from its usual position to the new position, that there was a shifting to the left, known as the phase shift. So if the phase shift is basically how much the graph moved horizontally, in this particular case, it was a negative pi/2. So the phase shift is used with the sign that you end up seeing. So minus pi/2. And because there is a minus here, you're always going to end up with the opposite sign. So it's going to be minus pi/2. So you're going to end up with positive pi/2. Let me use a different color so we can highlight that value. So positive pi/2. So that means that it's shifting to the left in the negative direction, but on the equation, it'll appear as positive. And finally, we need to find the period to figure out the k. We know that period is equal to 2 pi over k. And k is this value. You could use different names for that variable, but as long as you identify which value we're talking about, it doesn't matter if you call it k or b or anything you want. Now, this graph is going from here all the way to here. And if you notice, we have to see what's happening each squared. So from here to here, it is a pi/6. So each square represents a pi/6. So to get the absolute distance, we can consider a pi/6 on all of them. That's one way of approaching this. So you have 1 pi/6, 2, 3, 4, 5, 6, 7, 8. So you have a period of 8 pi/6. If you reduce this period, it's going to be 4 pi/3. So you can always simplify into little jumps to figure out the period. So that means that 4 pi/3 came from doing 2 pi/k. So this is the actual period, and you're going to solve for k. So in this case, we're going to end up with k being equal to, we're going to have 6 pi. So multiplying the 2 pi divided by 4 pi. And you're going to simplify that, so you cancel out the pi's. 6/3 can be written as 3/2. This is a coincidence that a and k end up having the same value, but notice that they came from different parts of the graph. So don't be fooled if you end up with A and K being the same, it doesn't mean that they will always be the same. This is a particular case with that particular solution, and this is our final equation.